All right, it's 8 o'clock now. I'm going to give it just a couple more minutes to see if anyone else shows up, and then we'll get started. So just about 2 more minutes, please. All right, it's 8:02, so we will go ahead and get started. So there is no new material from this week that needs to be covered. The only thing for this week, of course, was to do your final project, which is coming up due on Tuesday. So a lot of what we're going to talk about today will be driven by you. Any questions you have or any additional guidance you may need, feel free to speak up. But what I'll go ahead and do, I have the assignment up here in front of me. So I'll go ahead and give some examples that kind of relate to what you need to do for your final project. It won't be exact because, of course, I don't give out solutions to assignments, but it'll be somewhat related to what you need to do for your final assignment. So hopefully it gives you enough of an idea about what you need to do for your assignment to knock it out of the park. So, and some of what's in the final project was in other assignments as well. All right. So let's make up some kind of example that's somewhat like your final project, and we'll do an example. So let's start out with a list of names. Let's say we have names. Let's just make a list of names. Dan, Joe, Bob, Sue. Let's just leave it with 4 names right now to keep it short. All right. So that's a list of names, right? And if we print that out, of course, we're just going to get the entire list of names, right? Sure enough, there's all the names. Well, let's say we want to go through each name, and for each person, we want to record how old they are. Let's get their age, okay? And we want to keep that age, well, we'll get to that in a minute. So for now, let's just make a loop, and we'll ask each person's age. So how do we do a loop through a list of names? Well, we can do for name in names. And then here we do something, right? So what this does, it creates a loop that goes through all the names, but it goes through them one at a time. The first time in the loop, name will be Dan. Then the next time in the loop, the name will be Joe, and so on and so forth. So for our example, so far, let's just print out what name is. And we'll see that it'll print out the names, but only one of them at a time because it's each time it's going through the loop. Run it, and sure enough, there's all the same names, but they're being printed off one at a time. Okay. Well, now let's get how old. Let's ask how old is each person. All right. So say age is equal to, it's going to be an integer, and we'll ask for the input from the user. And we'll just say, how old is, and then we'll say the name. That looks like a pretty good prompt, right? So for the prompt, it'll just say how old is, it'll say the person's name, and then it'll just have like a little colon to indicate they should type it in, right? Okay. And then we'll just print out name and their age, just so we can see that we got the right input. So let's save this, let's run it. How old is Dan? 12. Oops, what did I do wrong? Okay. Not int. Oh, okay. I'm sorry. Since age is an integer, we have to convert it for display purposes. We have to convert it to a string. Let's save it and run it. I'll say Dan is 12. Okay. And then sure enough, if we look at our print here, we're printing out Dan and how old they typed in, which is 12. How old is Joe? Oops. Dang it. Dan. There we go. Dan is 12. Joe is 13. Bob is 14. Sue is 15. And sure enough, this loop took us through each name, and it allowed us to input the age for each name. Okay? Well, instead of age, let's ask what year they were born. And you'll see why we do this in a minute. Let's say, what year were you born? Save it and run it. Really no difference here. Oops, we should probably change our prompt. Instead of saying how old, we'll say, what year was blank born? That sounds like a better prompt. What year, other than me misspelling some stuff. Now let's run it. Okay, what year was Dan born? Say 1990. Oops. What to do? Oh, because I'm still printing name and age, but age doesn't exist anymore. I changed it to year. Save and run it. All right. Now, what year was Dan born? 1990. What year was Joey born? 1991. What year was Bob born? 1992. What year was Sue born? 1993. Okay, sure enough, it works. So, but let's say in our program, we want to record how old the person is. But now we're not asking their age anymore. We're asking what year they're born. So we need to somehow convert year to age. That sounds like a good idea for a function. Let's make a function called convert year born to age. As a parameter, it'll take the year they were born. And now we need to write the mathematical equation that converts from the year they were born into how old they were. So the age will be something like, we'll just take this year, 2021 minus the year born. And then we will return that age. Yeah, there's some edge cases in there where depending on what the month is, you may be a different age. You know, we're going to ignore that for this example. And we'll just say it's 2021, the current year, minus the year they were born. That's how old they are. So that's exactly what this function does. It takes year born as a parameter, and it returns how old they are by doing this math equation. All right. So here we're still going to ask what year they were born, but now we're going to compute the age. We're going to say their age is equal to this function, and as a parameter, we give it the year they were born. All right. So now in our little print, let's say we'll print their name, then we'll print the year, then we'll print their age. Just so you can see, we are converting the values properly. Save it and run it. Dan was born in 1990, and sure enough, it says Dan, born in 1990, is 31 years old. 1991, 1992, well, 1192. Bob is 829 years old. In 1993. Okay, so that works, right? So we were able to loop through each of the names. We ask what year you were born. We convert that to your age by using this function, and then we're just going to print it out. Okay. Well, instead of just printing it out, let's say we want a list of all of the ages. So let's have a new list called ages here. It starts out blank because until we ask the user, we don't know how old people are. I mean, if we knew, we could say they're 31, 32, 33, 34, 35 to kind of line up. 31 for Dan, 32 for Joe, 33 for Bob, 34 for Sue, and that would be all. You know, if we already knew their ages, but we don't know their ages. We don't know until we ask them to input it, right? So this will start off being blank ages. But now here, you know, we get the year from the keyboard, have them type it in. We compute the age with this function. Now let's save their age in this list. So we can have ages dot append this age that we computed. Okay. And now here at the end, let's print out the names and let's print out all of the ages, let's print out the whole list of names and the whole list of ages. And let's make sure that the ages look right. Let's save it and let's run it. Dan, 1990, 1991, 1992, 1993, and there we go. And so Dan is 31, Joe is 30, Bob is 29, Sue is 28. And does that make sense? It certainly does, because the age is 2021 minus the year. So 2021 minus 1993 is 28 years old, right? So what we were able to do, we were able to get the year, convert it to an age, and then store that age in a list. And now we have a list of names and a list of ages, right? So that's half the battle, right? Now let's see, we want to find out how many people are old and how many people are young, right? Well, obviously that depends on what their age is, right? So let's make a function that will tell us if somebody is old or somebody is young, right? Make a new function, find function, old or young, right? What parameter do we need to give this so we can determine if it's old or young? Well, we need to give it the age, right? So let's give it the age. So now we need to make some kind of mathematical comparison to determine if someone is old or young. Let's just say the age is 40, right? Let's say if someone is less than 40, they're young. If someone is 40 or greater, they're old. That sounds like a reasonable cutoff. Maybe not, but we'll say 40 is the cutoff, right? So if the age is less than 40, that means they're young, right? So let's just return young as a string. And you can see in a minute, this string can really be anything you want it to be, but you just need to be able to differentiate between young and old, right? So if their age is less than 40, they're young. Else, meaning if it's any other age, we're going to say they're old, right? And that's all there is to that function. There's our two functions. This function will take a year and it'll return the age. This function will take an age and it'll return if they're young or if they're old. All right. So now let's count up how many people are old and how many people are young. So say how many are old. I have a variable. It starts off to be 0 because so far we don't know how many are old, right? How many are young? And both of those start off to be 0, and that's because we haven't counted who's old or young yet. We've computed their ages, but we haven't figured out is that age old or young yet because we haven't used our old or young function. So let's make another loop for age in ages. And what does that loop over? So we have a list of ages, and we're going to loop over it saying for each age in that list of ages, well, let's figure out if that age is old or young. So if, we'll call our function, if the old or young of that age, if it returns young, then how many are young equals how many are young plus 1. Else if old or young, I'll explain this better in a second, equals old, then how many are old equals how many are old plus 1. And if it's neither one of those, if it's neither one of those, then something went wrong, right? Because our function only returns young or old. So if for some reason, and here we're accounting for it, if the return is young, if the return is old, else, meaning if it's not young or old, then something went wrong in our programming. Print, something went wrong with the program. If that happens. And you really don't need this in your program. I'm just doing it here to show you some other error checking you could do. Okay. And then here at the end, we'll print out number old. Oops, let's make it a string. Print number old. There, plus a string. How many are old? And then we'll say number of young. Oops. How many are young? All right, so let's explain this. Let's look at this more closely. So I've already talked about this a lot, these two functions. I've already explained this loop, how we get their age and append it to the ages list. And here we're still just going to print out those two lists. And that's a good way so that we can visually see, is it getting the old and young correct? All right. So now here's how we're counting up how many of them are old and how many of the people are young, right? So this is our old count. Starts off being 0 because we don't know yet. This is how many are young. Starts off with 0 because we don't yet know how many are young. So we'll loop for the age and ages. And actually, let's show you what that does. I'm going to cut all this out for a second. Let's just print age. So you see what that age actually is. So let's run this. We'll still say 1990, 1991, 1992, 1993. And there you can see there's all the names, there's all the ages. Now that is this loop for age and ages, meaning each time through the loop, it gets one of these ages in this list. So the first time the age is 31, then the age is 30, and so on and so forth. And then of course it's still printed these out as 0 because we didn't change them yet. All right. So we see that this age is going through the list of ages. So let's add this stuff back in. So now we'll call our function old or young on that one specific age. If it returns young, then we increase our young count. If it returns old, we increase our old count. Otherwise, something went wrong with the program, all right? And then at the end, we'll print them out. So let's save it and let's run it and see if it works. So let's create a bigger range of ages because we said 40 was the cutoff for old or young. So let's just make Dan really old. He's born in the year 1000. Joe was born in 1500. Bob was born in 1990. And Sue was born in 2000, right? So let's look at it. So according to this, this is how old each person is. Dan is 1021, Joe is 521, Bob is 31, and Sue is 21, right? And so if we ignore this down here for a second, just ignore it, just looking at the ages, mentally count up how many are old or young. We said 40 was the cutoff, right? If they are 40, see, where was it at? If the age is less than 40, they're young. So if they are 40 or greater, they're old, right? So these two numbers are 40 or greater. So we have 2 old and we have 2 young. And if we look up what our program computed, sure enough, it computed 2 old and 2 young. Let's just do some different numbers. Dan was born in, let's make one exactly 40. What would that be? Was that 1971? Let's see, 1981. Yeah, there we go. 1981. Joe's born in 1980. Bob was born in 1982. And Sue was born in 1983. If we look, Dan is 40. Joe is 41. Bob and Sue's age. If we see, again, we have 2 old and 2 young. And our program counts it up correctly. Let's do one more example of it. 2000, not 200, well, I'm putting 200, 2000, 1970, 1990. Oh, not, well, 199. So Dan is this old, Joe's 21, Bob's 51, Sue is that old, right? Sure enough, we have 3 of these ages that are 40 or greater. So we have 3 old and 1 young. Okay. So this entire example is very close to everything that you need to do for your assignment. It is not the assignment, but it is somewhat related to what you need to do for your final project. This is all the code there is. Just the short, 38 lines of code, but a lot of them are blank lines, right? So realistically, it's maybe 25 lines of code. Okay. So before I open it up for questions, let me just remind everybody that, of course, the final project is due Tuesday night, no later than 11:30 p.m. Eastern time. I cannot take this assignment late. I cannot stress that enough. You cannot submit this assignment late. I mean, the website locks, and you can't turn it in after 11:30 p.m. Eastern time. That goes for any past assignment that you would like to resubmit. The website will not let you submit anything after 11:30 p.m. Eastern Standard Time on Tuesday night. You have to have everything submitted then. And then what I'll do is either late Tuesday night or early Wednesday morning, I will ensure everything is graded, and then I will have your final grades computed. I will send out an email for you to look over your final grades. If you have an issue, you want to contest something, I'll give you 24 hours to contest it with me. Otherwise, that will be your final grade. So please get these in by Tuesday night, 11:30 p.m. Eastern time. There are no extensions on that. I cannot stress that enough. All right, so I'll go ahead and open it for questions. It can be for this final project or any other previous assignment or anything else about the class.
Hey, Professor, quick question. This is Will Selby. Was there a requirement to do like a compare and contrast the names and the results of the outputs? Like I see you kind of showed like, hey, Dan, Sue, Bill, Bob, and then it showed the numbers after it that kind of correlated with those names. Was that part of the assignment? Or is that just for an example to make things clear?
Yeah, that's really just to make things clear. Really, the only output, I believe, is how many people are underweight, how many are normal weight, and how many are overweight. It doesn't even need to be who is, in the various weight categories. It just needs to be a count of how many are in each category.
Copy that. Appreciate it, sir.
Yeah, Professor Ted. I have a question, please. My question is, so if you write a function with an if statement, what will happen if the if statement is not, your if statement does not end with else?
Which part in here are you referencing for my example?
So it's general, not specific, not any specific part of the function. But if you write an if statement and say if, let's see, elif, what happens if it doesn't end with else? Because I know else often is kind of like ends the function. Yeah.
Do you kind of mean like this function I have here?
Yeah, including that as well. But
Okay.
yeah.
So let's see what happens if we delete that. If we don't have that else statement. So let's see what happens.
We'll have a elif.
Okay. Let's say elif. What would you want for the elif?
Elif, age is greater than 40.
Like that?
Equal to, yeah.
Okay. Well, in this case, this would be actually perfectly fine. And you have to think about it. Why is that logically? And that's because no matter what age you put here, it will always be one of these two things, right? So it can only be here. So even if I put an else here, if this will never, ever, ever happen in this specific example. That's because if I put the age as 5, right, then this part happens, right? If I put the age as 40, this part happens. No matter what age you put here, it will always be this or this. And that's just because of the way we have our checks set up. Because if an age less than 40 or an age greater than or equal to 40, the age can't be anything else, right? But if we had something like if age is greater than, let's say 50, now we do have a gap, right? There's a 10-year gap in there to where it won't get caught in either one of those, right? It's like ages 41 through 49 won't catch in either of one of those, right? For example, if we have the age 42, is 42 less than 40? The answer is no. So
No.
it'll say, okay, else, is 42 greater than 50? The answer is no. So then it'll come down to this else statement. And so then we need to do something with it, return maybe middle age or something, right?
Mhm.
So that's when you need an else statement where there's a possibility it will not get caught by either one of these.
Okay.
But like I said, if we have this right here,
Then you
then
don't do the else.
right, then there's no way it could be anything different than one of these two if statements. It has to be one of those two.
Okay.
So that's where you can kind of leave off the else statement, or really you don't even need this check anymore. You can just say else, and that means, I mean, those two things mean the same thing. If we have L if age is greater than or equal to 40, these two things right here do the exact same thing.
Okay. Now, if you say if age is less or equal to 40,
Mm-hmm.
do this. If age is greater or equal to 40, you're going to run into problem. Is that right?
I wouldn't say it is a problem, but your code will run perfectly fine. Your code will not crash or anything like that. What'll happen is, if the age is 40, then this is true, so it'll always return young. So even though you put your age can be greater than or equal to 40, if the age is 40, it'll never get to this point
Okay.
because it already passed the check here.
Check.
So
Okay.
it doesn't even bother with this check.
Can be true twice.
Yeah, it can't be true twice. The first time it is true, that's what will happen, and then it skips the rest of it.
Okay.
But
But then this program you have a problem because you intend to say if it is equal, if it is greater or equal, then you should say oh, and if it doesn't say oh, then that means even though the program run perfectly, but then the program has a problem.
right, well, I mean, I wouldn't put both of them equal to. I would say one of them needs to be equal to,
Yeah. That's a
and
question.
right, and this is fine.
Okay.
One thing I was going to mention, I thought you were going to lead in this direction. You didn't, but I'm going to talk about it for a second because I've seen problems with assignments being turned in. Let's say we have that gap in there. Remember, I talked about that gap, that 10-year gap, right? So if the age is 41 through 49, then what happens, right? So let's just say an age is 41. Let's call our function. Let's say the result is old or young with that age. And then we'll print the result. And right now, I'm just going to delete the rest of this. I don't need it. Actually, let's start out with 39. See what happens. So we'll say the age is 39, and we'll get the result of that function, and we'll print it out. So if they're 39, it prints they're young, right? If they are 50, it'll print they're old. What happens if they're in one of those in-between ages that we don't account for? Let's say 42. So, that's not true. 42 is not less than 40. So it goes to the next check. 42 is not greater than or equal to 50. So it goes to the next check, but there is no next check. So what is the result here? This is a problem with your program. If you run this, the result is none. We've talked about before, none does not mean zero. None means it has no value at all. And that's because, this was not true. This was not true. So what did it return? It didn't return anything. This would be a good candidate for that else, where we can return whatever we want.
Okay.
So that now when we run this, we don't have that in between like gap in ages, right? We get, whatever we want to hear. And, maybe we want it to be middle age or something, whatever you want to call it. But you have to make sure you account for all the possibilities of age. So if with the if and else if we left that gap in there of 10 years, we have to make sure we account for that 10 years somewhere. And that's kind of what I did with the else statement here. So that's why I think if you don't have an else statement, I consider that kind of a warning sign. It doesn't always mean there's a problem, but I say it usually means there's a problem if you don't have an else statement. So I think an else statement is usually something you should have at the end of any of these if elif things.
Yeah. Okay. If there's any project or assignments that anyone want to redo, how is this submitted? Through email or what?
Nope, you can just, if there's any assignment that you would like to do over again, you can just go back to it on the course site and upload it like you did the first time. The website will keep track of every submission you make, and I'll get like a notification, and I'll just regrade the most recent one that you submitted. Do keep in mind two caveats with that. One, there is a late point penalty if you resubmit an assignment, just like there's late point penalty for any assignment that you submit. So you have to keep in mind there's that point deduction off the top. So you need to look at your current grade, and obviously the max you can make on any reassignment is an 85 because of the late point penalty. So if your assignment if an assignment grade is less than an 85, then you certainly have room to improve your assignment score. If you would resubmit an assignment and you got everything right, it would end up resulting in an 85 with the late penalty. But that could be an improvement on your score. And if for some reason it ends up being worse, I will keep whichever was the highest of the two.
Okay. Great. So with these, with the example that you gave, I think it kind of cleared. Is there anything? And I'm not saying you should go ahead and give answer to the exam, but is there anything that is that set these two apart? that is not included in the exam in the example that we can kind of watch for?
No,
Because
yeah, I don't think there's really anything in the final project that wasn't kind of covered in the example. The example had everything in it
okay,
that your assignment needs to have.
except it's not the exact. Okay. All right.
Yeah, I mean, obviously for your assignment, it's talking about body weight and are they underweight, normal weight, or overweight and stuff like that. And we did ages, so
Mhm.
it's somewhat comparable, but not the exact same. All right, I will hold on for a few more minutes if anyone has any questions. If not, like I said, I'll hold on for a couple more minutes. I'll get the video posted up here in a little bit and put the link on the course website. And like I said, the deadline is hard and fast, so please make sure you make that deadline. And you can always also email me for any assistance you need between now and then.
Sure.